All right. Hey, everyone. I'm Mark, and welcome to part 2 of tea. So in a previous video, which I'll also link down in the show notes and probably somewhere up here, I talked about the tea CLI, right? The command line interface, how you're interacting and using tea. And in that video, I also mentioned that there's going to be a second part, which is this video, and it's all about the pantry and what the pantry really is. Let's dive in. So if we click on this link, or we just look through the repositories, we will find that there's actually 3 pantries. One is called pantry.zero. One is called pantry.core, which is a fork of pantry.zero. And one is called pantry.extra. And I've written a little bit about kind of what are pantries, taking a jab at the README here of what tea has provided. And if you want to know more about kind of what are pantries, highly suggest that you check out the pantry.zero repo first, because all the other pantries or all the other repos will point you to pantry.zero to kind of getting to know how to contribute. So pantry.zero is where we're going to start. What it mentions here in the top is that really tea is a decentralized package manager. And in the previous video, we understood that tea is that universal packaging infrastructure that includes obviously a package manager. And what we didn't know before yet is that it's actually a decentralized package manager. So that means that it requires also a decentralized package registry. And we're diving in here to understand really how this is set up and what actually works today and what works in the future. So let's dive into this pantry.zero repo, as it's called, funny enough, the root of all pantries. So pantries itself are kind of the metadata about open source packages. So this is where you would typically commit and package certain projects for an open source project that you want to have distributed through tea. You would have to kind of write a specific YAML file, and we'll get into this in a bit, to really package it up that tea can understand, read it, build it, and then distribute it for you. So today, and that's why we also have kind of these 3 repos, one being the core, the root, and then one there's called pantry.core, which are the core, libraries, super essential, open source. So this contains all your, programming languages, interpreters, compilers, and just core libraries. And then we've got pantry.extra, which is kind of this is where you would like to contribute if you have a package to package it up for the tea ecosystem. And this contains, everything. So we've got, things like Solidity in there. We've got htop in there, and all sorts of projects that, are not so essential that they need to be in core, but they can obviously be upgraded from extra to core if they're deemed, very essential. In any case, you will have all of these packages available with your tea command. And further down the road, what actually is the reasoning behind having this pantry.zero, right, the root of all pantries, is that any fork of the pantry means you, as a developer, you could host your own pantry, basically your own registry with your own packages. And because it's a fork of pantry.zero, tea would understand that this is, part of the tea universe, and would also make available these packages that are living in your fork to the rest of the tea users. So you could imagine that there's a designated pantry for Web3 projects, for example, or packages, or a designated pantry for artificial intelligence or machine learning. we could also have a designated pantry for all things analytics. And so, we could go into all these different verticals as niche as possible. But for now, what we want to understand is, okay, there's 2 core pantries. And if we're packaging our own project or someone else's project, this should be contributed to the pantry.extra. Great. And, this feature of all the forks is not yet implemented. However, there is certain workarounds how you can do this. And I'll probably get into this and maybe in another video about packaging. But primarily, you should focus on packaging for pantry.extra. There's a contributing guide as well here on the README, and this basically tells you how you can go ahead and package a project. And I'm gonna jump over here to kind of like the documentation, which I've documented a little bit more verbose, I would say. But essentially, what the beginning part I already mentioned. The great thing is it uses a really open format called with YAML. It's very like non-proprietary open format that could also be interpreted technically by any other. Plus, you don't need a specific compiler to run this, such as like with JSON. And the structure of a pantry is quite simple. So there's in the root directory there sits a projects folder. And within the projects folder, there are various packages, always with a fully qualified domain name that is a unique identifier to this particular package or host of packages. So a package can also contain multiple packages. In the example of package B, for example, it contains another package that then contains a package.yml file, and this is the core file. Really the only file that matters for a package. It's very simple, and can also jump into kind of like how this package YAML looks like. I will do this in a bit. But what you should know is that you want to create a new unique identifier for your particular package inside the projects directory, and then within that package directory, you want to initiate or open a file called package.yml. So I've mentioned that there's kind of like 2 ways to create a package at the moment. But however, the first way of creating a package, which involves you kind of like forking pantry.zero, is not fully implemented yet. So it's recommended that you contribute a package to the pantry.extra. And we'll jump ahead to kind of like point 2 here of contributing a package. So it's quite straightforward. It tells you, fork pantry.extra, right? You always, if you contribute to an open source project, you always want to work on in your own fork and then open a pull request. Within that fork, we're going to open or check out a new branch. In this example, the branch is actually called the same name as the package. So, it's going to say it's an example package. And then we've got a step-by-step guide. And finally, you want to open a pull request to pantry.extra. And the step-by-step guide is also quite straightforward. And this is what we're going to actually jump in now. So let me just dive into my folder structure here. Perfect. So I'm kind of like in a Scratch file here where I'm like working on. And first I want to, if you don't have tea installed, you want to install tea. I've got it installed already, but what it does, executing this command, it will just look if there's an updated version, and if so, it will update this. Well, I've already the latest version installed, so no need to update. For you, it may be outdated or not. Perfect. So next up, I'm gonna make another, just a folder that kind of like contains all these following packages. I'm just gonna call this like package.dev and cd into that. And then I want to clone, the CLI project in here. I want to clone the pantry.core, and I'm cloning not forks of the CLI or forks of the pantry.core, although this might be also possible. But the CLI has certain dependencies with the pantry.core and the tcli that you have installed on your machine. So you also always want to have them kind of like the CLI repo and the CLI that is installed on your machine. They always should be on the same version or the same source code. So in this case, version 17.1. And I can be pretty sure that if I've updated my CLI here and I've got version 17.1 and I did a clean clone from the CLI of GitHub at the same time, that they're on par with the same version. And then finally, the pantry.core is necessary because here are all the build scripts and the test scripts for building my packages or package.yml file. So I also want to have these. And then finally, I want a clone of the GitHub pantry. And if I go to the pantry, I already have a clone. So I'm just going to jump over to this, and you can see that I have not a clone, a fork. And I'm just going to copy this, jump back in here, git clone, and then I'm going to clone my package. So I should have all three of these packages in here. Finally, with ls, just confirming that my fork is also in here. Again, here it's mentioned, you want to have both of these on the same checkout, on the same installation up to date. And yeah, finally, before you create a new package, you always want to double check that, the package that you want to create doesn't currently exist. So what we do is, we open up the pantry, the combined pantry of both core and extra, and we can browse it here in our terminal. Down the road, I'm pretty sure they're gonna create a better, UX for this. But for now, it's totally sufficient. You could also obviously go into the kind of like the pantry.extra, look through the projects here, and then go to core and look through the projects folder here. So that's just a way of combining everything on your system and looking, if there's a project that you want to package that has already been packaged. If not, great, you can go ahead and package this. Okay, perfect. So next step, I want to kind of like check out a new branch in the pantry.extra, because this is where we want to eventually then commit and open a pull request on pantry.extra. And then I'm just gonna git checkout. Let's call it htop.dev. All right. That's because I want to kind of like build a project called htop. And because this video is just an example, it's gonna, depending on how big and how massive your package is, the package YAML can be, very complicated or very simple. So furthermore, I can check that there's, in my projects folder, what I want to do is I want to go to my projects folder, and I actually see, there is something called htop.dev already. But if not, what you want to do here is you type make dir and then htop.dev, and that is because htop actually has a fully qualified domain name. It sits under htop.dev. That's why I named the package this way, because there's a very low likelihood that there's another package with the same domain if htop owns that domain. So that's why we're using the fully qualified domain name here as a unique identifier for this package. If you happen to come across a project that may not have a home by itself, what we do here, most of the projects are kind of like hosted on GitHub. So there are a bunch of projects that live inside github.com because they're just hosted on GitHub. So one is, for example, YQ. This is actually hosted by Mike Farah, or NumaCTL, right? And these are actually GitHub/NumaCTL/NumaCTL is the actual root of the project. So that's how kind of like the domains, the name spacing has been created for these projects because they don't have their own home at the moment. But that's totally fine for me. htop has its own home, so what we can do is we create this htop.dev. In this case, it already exists, and because this is a video showing you how it works, let me just open this in Visual Studio Code, so it's a bit easier for me to navigate. I'll trust the authors. Great. So what I'll do is I'll just copy the contents here, and I'm going to delete this folder so that we can go through it, one by one. Okay, perfect. So I'm just going to make so just to double check, ls htop.dev doesn't exist. So make in the projects directory, htop.dev. Perfect, that exists now. I'll go back into the Visual Studio Code because it's just easier that way. However, if you just want to copy this, you want to touch let me just do this here as well. Touch htop.dev, and then I want to open a package YAML file. So now I've created a package YAML file within this directory. And now it really gets to the gist of it, right? Now we're editing the package YAML file, and the package YAML file has a very basic structure. It's all written in YAML, so indenting is extremely important. And let me just all right. So here's an example of kind of like a base package YAML file. So the package YAML file is kind of like the core of building new software, right? They can be, very difficult or very easy. In case of the just systems package YAML file, it's quite straightforward. It's just a mere 28 lines of code. But even the Python package YAML file is also not that much longer. It's 128 lines of code, so roughly 100 lines of code more. However, it does have a lot more dependencies, and compared to just 3 here in the just systems, and of course the build process is a lot more intricate, a lot more moving parts here, where you really have to understand how it's built. Whereas just systems is just it's a cargo project in Rust. So all it does is cargo install, and that's about it. Well, the first thing you want to make sure is that the project that you're building, kind of that you understand what are the build instructions, and that kind of like what are whether runtime or build time dependencies exist, and that you can kind of like find them in the repository or in the documentation or somewhere where you understand how to build this package from scratch. So from source. So in the htop.dev case, there is a compile from source, and it tells me exactly how to compile this. There's that autogen.sh, there's the configure, and then there's a make. And finally, to install it, there's a make install command, and I can configure a prefix, and we'll get to this in a bit. Great. So let me copy this here because there's several steps that we need to do first. So I've got my package.yml file within the htop.dev. I copy the example. We need to properly indent the URL of the distributable. And there's a very good, explanation of the structure right here. So, what each of the YAML keys really mean and how they're being used. So we've got the distributable. It's kind of like one of the most important one. It tells the build process really where to fetch that package. And typically, in our case of htop, that's gonna be mostly the the releases folder in GitHub, and for most cases, whenever there's a tarball being released on GitHub, that's where you want to get it because this is probably the most up-to-date place. Sometimes it's also hosted on their own websites on a download registry, so be aware of that. But most of the time, you will find it in GitHub, or there's like some explanation of where you can find this. And so we specify a URL here. In the case of htop, what we have is, in the case of htop, there you go. We have kind of like htop.dev, releases, download, and then we're using these placeholder variables for a version, because the version is actually, T makes it so that you don't have to package each individual version, but once it's packaged once and there is a way to get the next bigger version, whether it's a patch update or patch release or a minor release or a major release, T will understand that and will be able to kind of like fetch this from the versions tag. So in the versions tag, there is also something called GitHub. And what we do here is we can, instead of hard coding a version, we're using a GitHub key to point to the tags directory or the tags path of htop.dev. So if we just type in this htop.dev, htop tags, we'll see here that we get a chronological list of all the versions that are being released alongside with their tar-zip file. So great, that's perfect. Then finally, we want to add a provides key. So the build process will provide kind of like a binary, and where this binary is located is kind of dependent on the kind of like relative to the prefix. The prefix actually is your place where the T directory is installed. So in my case, it's the home directory.t folder. And then I'm just gonna add kind of like the remaining steps of the build process and the dependencies so that you can see how that entire file looks like. So we've got a dependencies key, and then we've got a build, and within the build, we've got a sub key also called dependencies. So this dependency key is a runtime dependency, and you will see that here in the explanation. It's actually in the pantry.zero wiki, structure of a package. I will link these links below that you will find them very easily. So that's a runtime key, and they're also made available to the build process. So we don't need to replicate them here or like duplicate them. And then finally, we've got a build key with a subkey of dependencies and a subkey script and a subkey of test. So testing the build process, and then finally creating a script of how to build this. And as we saw in htop.dev in the README, it actually showed us how we can build it from source. And if you remember, we do have this configure and make. We don't need to call autogen, although you can call this. However, there's also already a configure file, and this is a typical C pipeline. So configure and then make, and then finally make install. And that's exactly what we have. What we do have specifically here in the configure, we're designating a path where, this binary should be installed to. And we're calling here a prefix because the prefix is also a variable similar to the version, and it will be passed on what your t prefix is. So in my case, it's the .t directory, but you can also have any other thing, call it. And then you've got make and make install. And finally, we test the build process. And ultimately, we also want to have a test that tests the binary. So this tests the binary. It runs htop -h. Perfect. And that's about it. And we can save this. And we want to make sure that this package that we have created and this package YAML is actually building. So here's again explained what kind of like the prefix looks like, and also the test script, but we want to kind of like build the new package. And there are a couple of requirements. So you need to have your Xcode command line if you're working on a Mac, or you need a libc dev if you're working on Linux. So make sure you've got this installed. This typically should be up to date, but sometimes you're missing an update. So make sure this is installed. If you don't have Xcode generally installed, you have to run this. Otherwise, it will throw an error. In order to build this package, what we need is a kind of like a permissionless GitHub token in our environment, in our secret. In our environment secret path. And what I'll do is I'll just open up this here, and let me just have a look at my environment, what I already have in here and what I don't have in here. So if I'm checking, it doesn't look like I have a GitHub token yet. So what I'll do, but I have GH installed. So perfect. What I'll do here is I'm just gonna take the token that GH has here and just gonna export this. So I'm just gonna export token and then GH auth token. And that's just a command I know from the GitHub CLI. And this will paste the token in here. Oops, my bad. There should be nothing like this. Great. And then finally, we want to export the T pantry path. Again, this should be without the dollar symbol. That's only when you want to call the environment variable. So export T pantry path to the current path and to pantry.extra. Perfect. So if I then go back to where I have my pantry.core, pantry.extra, and CLI, what I can do is I can just call this example here. So pantry.core scripts build.ts and then htop.dev. And if I run this, it will understand, it will prepend two pantries. So we have this extra pantry path, and it will prepend this pantry path, a lot of P's here, to the installation, it will, and then it will kind of like run the build script right here on this package or on this package YAML. So if we hit enter, obviously we've got path not found. Okay, the t-pantry path was actually wrong. So now I've updated the pantry path, and now that's correct. So before it was looking at dev t package, pantry.extra, and then projects, and pantry.extra in projects. So that's obviously incorrect. So now this is correct. It's looking for the pantry.extra in the package.dev directory, which is where we are, and here's the pantry.extra. So apologies, but that's how it works in a video. So now I'm running the build script, and that works. It's downloading Dino in order to run the kind of like the build TS script here. And it's running all the other kind of like required dependencies in order to run this, including the dependencies that I've specified here. So autoconf, a C compiler, automake, ncurses, etc. And then it will just start building the project. And yeah, once everything is kind of like finished, it will show you a a success message that the build has not failed. That's always good, but most likely is the build will fail. It's always getting it right does take some time unless you're super experienced. But in any case, if you attempt and you need any help, you can always then open a PR or a draft PR in the pantry.extra repo, and then the T staff, they're super responsive and really want to help you also in getting your package built and getting you on as a contributor also to this project. Also, if you have any troubles understanding how you should package a particular project, for example, you're building a Rust package, for example, right? Like the just systems that we saw. It's always helpful to look at other package YAML files that are currently either in the pantry.core or the pantry.extra. So that way you can learn a bit more about how did they build it, the build scripts, how do they test, what kind of dependencies are there, and yeah, same with let's say Ruby gems, gist. It's a very easy it's basically a gem from Ruby, so it requires the rake install command in order to build that package. It's the defunct gist package. There's also other packages like where was it? YouTube.dl. Right, the YouTube.dl package is a bit more complex. As you can see, it also requires moving files around, and it has a dependencies on Python, so it does require a bit more work here. But a lot of the packages, whether they're using the C build pipeline or Rust or another package manager, whether it's npm or Ruby gems, for example, then it could be quite straightforward. Without Bode's BPP, kind of like a GPG alternative, it's also just dependent on cargo, and just do cargo install, and that's it. So in the meantime, the htop build properly, and we can see also where it was installed to. So the final command was make install, and it was installed to our home directory .t and then htop.dev version 3.1 in that bin. And if we look into kind of like the home, so let's look into home, into our T directory. We've got that right here. We've got htop.dev, and we've got the appropriate version in the bin, and we've got htop as a binary. And you can see it's a Unix executable file here inside the bin, exactly how we specified where it should be. We can also see the source code because we built it locally. So we've also kind of like stowed away our source code here. That's the entire repo or the tarball that's been installed. So if you want to debug something, right, this is also where you can go and look at where the output is. So yeah, that's kind of like it until here. Finally, we can also test the package, and we'll go back here. So this has built properly, and now let's test it. htop.dev. We're running, and boom, it did execute the test properly. So the test was, if we go back to htop, was calling htop -h, which is that's the help menu, but it worked properly, and we have it right here. So it seems like everything is great, and I can actually go up here and open a pull request to the pantry.extra, and if I just go back to pantry.extra and I go to git status, I can see, okay, I've got a modified file, right? Now you want to go up and commit it and push it up to your fork, and then open a pull request on the pantry.extra, and then it lands here. The team gets notified, and we can add it to the pantry once all the once all the kind of like test pipe and CI in GitHub Action passes. Here we see it doesn't pass yet 100% for the AWS CLI, but once all the tests pass, you will get a green check next to your project, kind of like this. All the CI has passed, 14 of 14 checks, and then it's ready to merge. If you need any help, you can open it as a draft, and the team will jump in and help you. All right. Thank you so much for joining me in this kind of like a long video, but I hope you learned something. And if you have any questions, happy to help you. And thanks so much for listening. I'll see you in the next video.